Dear students, faculty members, Dean, and invited speaker, Pratishta and I welcome you all to the Nalanda. Nalanda is an unusual event that brings our students in close contact with deep thinkers. The idea of the Nalanda is to learn through questioning and dialogue, to build independent mindedness amongst our students, and to learn to engage with an issue or an idea and build confidence by engaging closely with someone who has thought very deeply about it. We believe this is inspiring and transformational. Today, we will try to understand education to enhance academic intelligence. It is a pleasure to introduce Professor K P Mohanan, an internationally well-known theoretical linguist, as the first speaker of this season's Nalanda. He did his BSc in physics, MA in English literature, and then PhD in linguistics from MIT. His academic career profile is spanned across the globe. He held academic positions at University of Texas, Austin, Stanford, National University of Singapore, and most recently at ISER Pune. He has passion for education and a deep interest in basis for beliefs across disciplines. He is also the co-founder of ThinkQ, an online education platform which recognizes inquiry, integration, and deep understanding as the crucial components of academic intelligence. He will be in conversation with Professor Ashwin Kumar from the Center of Learning Futures at Ahmedabad University. Ashwin is equally passionate about education. Ashwin, please go ahead.
Thank you, Subhash, and welcome, Professor Mohanan. This is roughly the format we'll try and follow for the evening. I'll set the stage with about some 20 minutes of back and forth with you, and then we open it up for the students. In Nalanda especially, we have a convention where the students ask questions, and only then do the faculty members, who are literally the last benchers in this event, do they get to ask the questions. Let's begin by some bit of a retrospective on your own journey. You were a linguist, but today you call yourself something of a general practitioner of knowledge and education. What is this change? How do you understand this, and what does this hold for us as a lesson? You know, what is the general practitioner doing amidst us in the field of academics?
Okay, I think the transition happened when I moved away from teaching PhD students at Stanford to teaching undergraduate students in the National University of Singapore. So if you're doing a PhD in linguistics, we expect those people to become linguists, obviously, to do research in linguistics. That was a highly specialized activity. But when I moved from that to teaching undergraduate students in linguistics, the first question was, the people who get a degree in linguistics, undergraduate degree in linguistics, are not going to become linguists. Maybe 1 out of 100 will continue to do masters and PhD in linguistics. The rest of them will pursue other paths. What is the value of linguistics education for those students? If some of them might become managers, others might become dancers, others might become historians, housewives, various. So these are going to be people who have nothing to do with linguistics later. And so I have to justify what I was teaching for those students, if it is not going to be a total waste of time. So the only answer I could get at that point was, there are certain characteristic ways of thinking, certain modes of mind that are characteristic of linguistics as a scientific discipline, that would be of value to all parts of life. And so we focused on those things. So how do you construct a linguistic theory? How do you come up with a linguistic analysis? How do you come up with an argument for a position in linguistics? Those are things that can be transferred to other domains of life. And then it occurred to me the same thing applies to physics, mathematics, biology, except for disciplines like medicine, law, where you are very clear that you want to pursue those careers. These other disciplines have the same characteristics. Somebody who graduates in physics may not become a physicist. As in my own case, I have an undergraduate degree in physics, and I ask myself the question, how is that of value to me as a non-physicist? And the answer was very little. So I don't even remember what Ohm's law is. Many of the things that I learned, for example, calculus, I don't remember many of the things. I don't know now how to calculate the path of a cannonball. I did that as a student, but after that you forget. However, certain things remain. For example, a certain ability to do formal thinking that I learned in physics. That is useful. Certain understanding of the distinction between what you observe and what you hypothesize in your theory. The difference between what you can observe, a stone falling, and the concept of gravity, which is unobservable. Those things have become part of my thinking. So this is what I took from physics. And then it occurred to me that education should really develop those abilities that are transferable across domains, not highly discipline-specific things, at least undergraduate education. PhD education is different. So I became a generalist. So I started studying mathematics, I started studying biology, I started studying philosophy to figure out if there is a way of integrating all these modes of thinking. So I became a general practitioner.
Right. That's, you therefore probably use the concept of transdisciplinarity. I was also intrigued by your understanding of the notion of transdisciplinarity. Maybe I should just explain to those of you who might not have had the time to read some of the articles that Professor Mohanan shared with us. Now, his concept of transdisciplinarity. Now, I can assure you that I have come across probably half a dozen conceptions of transdisciplinarity, and this was the first concrete understanding, that concrete but also powerful and abstract understanding of transdisciplinarity that I came across. So it sort of, my attention got really hooked there. So Professor Mohanan understands transdisciplinarity in the following way. Think of physics, it gives you the structure of an atom. Think of linguistics, it gives you the structure of a sentence. Think of literary criticism, it gives you the structure of a sonnet. So you're studying the structure of these different things in different disciplines. But the idea of structure itself is something that spans across these disciplines. The study of these kind of things, the study of structure, for instance, or the study of, relationality, these kind of things would form a transdisciplinary pursuit, if I've got you correctly. One of the things I was intrigued by was this. Knowledge usually is knowledge of something, right? So knowledge of an atom, knowledge of a sentence. What is this transdisciplinary knowledge of? If you were to say it's knowledge of structure, what does that mean? I mean, is it seems somewhat difficult to grasp that.
Yeah. So let me kind of go through different levels of knowledge. So you can have knowledge of the motion of inanimate objects, which is what you get in Newton's theory or Einstein's theory. But now that knowledge consists of concepts like gravity, acceleration, velocity, mass, weight. So if you say knowledge of Newton's theory, you're not talking about knowledge of the phenomena of falling bodies and other things, but the second level of knowledge. So there is a way of saying knowledge of such and such concepts, or knowledge of heliocentric theory, or knowledge of geocentric theory. Now you are at the next level. And these theories have concepts. Concepts like gravity, concepts like motion, concepts like selection, mutation, and so on. Many of these are new discipline-specific concepts. But if you look at motion, you can unpack it as change of location. That's what motion is about. And in evolution, biological evolution, there is a change of the attributes of a biological organism. You can talk about historical change. Change now becomes the next level of knowledge. Now, transdisciplinary knowledge is knowledge of those concepts that exist above the level of disciplines, across disciplines. So, when I say something like, I have some understanding of the concept of theory. Which theory? Doesn't matter. Theory that cuts across mathematical theories, scientific theories, philosophical theories. I have some understanding of the concept of argument. Again, mathematical proofs, philosophical arguments, legal arguments. So these are concepts and propositions that exist above the level of disciplines. That is what it is. So this is the third tier. Observations, the phenomena, the theory, and the next level.
Sure. If I'm wondering if one can speak from a point of view of a 17, 18, 19-year-old, what role does this kind of knowledge play in a typical undergraduate's education? Why are you saying I should not be spending time studying physics and studying, and why should I be spending time studying structure? Now, you're sort of playing with our minds, aren't you?
Okay, I wasn't actually saying that we shouldn't spend time studying physics. It is important to study physics, but study physics in such a way that some of those things are transferable beyond physics. So those are the things which are more of value. So if you look at, for example, the concept of inertia and force, you find something very interesting between the change from Aristotle to Galileo. Galileo thought of inertia as absence of motion. Sorry, I meant Aristotle thought of inertia as absence of motion, but Galileo changed that to not absence of motion, but change in uniform velocity. And the same way, force, the concept of force was also changed. Now, if you now generalize from that to study of the inertia as a transdisciplinary notion, the default state of affairs is inertia, and force is that which changes the default state of affairs. Now you can use that concept to study things across disciplines.
Sure.
So you become free to move across disciplines and learn anything that you want in a much freer way. It's a very powerful tool. That's one. The other is it also helps you to do research in a much better way. So take, for example, biological evolution and consider its relation to history. History we think of as human history. What about the history of the universe? History of life on Earth. Now history becomes a transdisciplinary notion. And then you look at historical change. The notion change as in biological evolution, as in the evolution of the universe, and the evolution of human cultures and political systems. The notion evolution then becomes an important transdisciplinary concept. The evolution of the universe, evolution of life on Earth, evolution of human cultures as a single concept. Now you ask the question, what is evolution? You understand biological evolution much better that way. The distinction between evolutionary change and non-evolutionary historical change. Nobody thinks of Darwin as a historian. He was a historian of life on Earth. Okay. If you would develop that understanding, it becomes much easier to learn varieties of subjects without difficulty. You also become capable of doing research, and you become capable of talking across disciplines and learn from each other.
Sure.
So this is a very powerful way of both learning and doing research.
So what you're saying seems to be demanding a new set of, let's say, skills, abilities, both from the student and the instructor and the teacher. From at least the perspective of a teacher, there are these two extremes, right, which most of us deal with. One is to say, I do my research, which is in something completely esoteric or niche, and probably beyond some 4 or 5 people in this universe, no one else might even care about it. And then I'm going to teach you something that you anyway ought to learn. So that's one extreme form of deviance between what you do and what you teach. I'm sure that's probably not a desirable state to be in. There's the other extreme, which is to say, my job is to measure, half-life of an isotope as a researcher, and as a teacher, I'm going to teach you how to measure half-life of an isotope. Probably this is also not a very desirable state, because this absolute thing is just reducing the horizon of teaching. Teaching is not simply making you do the same set of tasks that I do. It needs to probably have a larger horizon. How do you redescribe, reconfigure the teacher and the student, their functions, their roles, the typical cognitive habits they bring to the classroom in this new transdisciplinary culture?
That's actually a very interesting question, because every teacher, in one sense, clones himself or herself. So when I say transdisciplinary thinking is important, what I'm saying is I have struggled for 40 years to acquire certain abilities, and what I have acquired is important for students. Now, that is an extremely egocentric statement. Okay. The parents do this. Parents who are doctors want their children to become doctors. Educators also do the same thing. They want their students to become them later, so that they can continue through their students. And I'm aware of that danger. Along with that also is the desire that what I teach has to be of value to the students. Not because you think it is important, but because it is going to be important for their life. So you have to struggle with these two in a difficult way. So the question to ask is, for a teacher, what is it that I'm good at? Understand that. And then, what is it that is of value to students? And if they coincide, then you focus on that. Obviously, there are many things I will not be able to teach because I am not good at many of those things. Okay, so for example, if some student wanted to learn how to invest in stock market, and they come and ask me, I can't do that. If somebody came to me and said, teach me how to write poetry, I say, sorry, go somewhere else. So there are many things I can't do as a teacher, but these are valuable things. And so the statement about transdisciplinarity is, I think this is of value to everybody, because these tools of thinking, these tools of reflection are valuable in every domain of life, in your private life, in your professional life, in your public life. And including things like, consider the following. You are walking across the street, and there is a friend of yours coming from that direction, and that person doesn't look at you, and your immediate interpretation is, oh, he doesn't like me anymore. Most friendships are broken because of interpretation of facial expressions, interpretation of words, and so on. If you are a good scientist, you should know the difference between the symptoms and the actual underlying causes. And maybe that person didn't look at you because that person was thinking about something, was totally absorbed. I do that all the time. So you must be distrustful of interpreting things only in one way. This applies all over the place. As I said, in private lives, all the way to public lives. So, since I'm committed to the view that this is of value to everybody, I hope that my attempt to clone myself and students is not a selfish, egocentric thing. I also pay attention to this. So this is where the two interests coincide, my interests and the students' interests. So I don't feel guilty in doing this.
There's something else that I found interesting in some of your writing. Recently we've been talking about the education policy, especially in the context of national education policy. I read, I don't remember now the author, but I remember this person is a retired bureaucrat from the Government of India, not even from the Department of Education, but probably revenue or something like that. He had a very scathing criticism of the education policy. Many people are saying there are quite a few good things in it, but his criticism stood out for me. He said, look, don't give us another model all over again. We have models and models and models piled up. Just tell us, in the last 50, 60 years, you spent so much money, so many resources, and these things haven't worked. So first give us a diagnosis of why these initiatives haven't worked until now, and based on the diagnosis, we can produce some kind of specific targeted solutions. So a good policy today in education must not be giving some grand picture of what is the goal of education and what is the structure of institutions, because those things exist. You don't need to reinvent the wheel. What you need to do is to do a diagnostic exercise. Now I found in what you have been talking about some such attempt in saying that there's a crisis in learning in the Indian higher education system, and that is what has to be addressed. It's not about what's the funding that goes into IITs versus IIMs, or whether you want to have 4-year degrees or 3-year degrees. I mean, those are things you can sort out by the by, but how do you diagnose the ingredients of this crisis in learning, which seems to be a large-scale phenomenon? So can you reflect a little bit on that to place this in context?
Okay, let me attempt something slightly, not exactly the same, but slightly related.
Sure.
Rather than doing a diagnosis of the existing problem, let me use 2 or 3 words in the national education policy.
Yeah.
So they use words like critical thinking, problem solving. I think they also use the words inquiry. I'm not absolutely sure. These are words, fancy words, buzzwords that everybody uses. In just about every educational policy, you have these words.
They use trans-disciplinary too.
They don't use, I didn't find that in the national education policy.
Okay.
Did they use it?
Yeah,
Okay, it's there in one of the UGC documents,
yeah.
Trans-disciplinarity. Okay, now let me just take critical thinking. Now, I have asked various people, how will you teach critical thinking if you're teaching mathematics? How will you design a question paper such that it tests critical thinking? How will critical thinking be incorporated in a textbook? Nobody seems to have any idea, because they have not unpacked the word critical thinking. They have not defined the concept of critical thinking, and they have not worked out the logical consequences of subscribing to that concept. Now, if you say critical thinking is evaluating the merit of something, whether something is a proposition, it can be a policy, it can be a product, and then you ask evaluating, how will I teach my students how to evaluate theories? How do I teach my students how to evaluate evolutionary theory? You immediately see that these things are not taught. Okay? The people are taught how to accept theories and apply theories, but they are not taught to stand back and say, why should I believe that all life forms on earth evolved from unicellular ancestors? Why should I believe that the earth revolves around the sun, because my experience tells me that the earth is stationary? Why should I believe you? Unless the student asks that question and the textbooks and the teachers address those questions, and the examination questions probe into those abilities, there is no critical thinking. So, does anybody teach you how to evaluate proofs? No. Evaluating proofs is part of critical thinking in mathematics. Okay. So, the entire curriculum should shift if you subscribe to the idea of critical thinking. Syllabus, textbooks, and the design of exam questions should reflect that. Right now, there is no connection between them. So here is a question I would like to ask. You have learned heliocentric theory, which says that the earth revolves around the sun and spins with the axis tilted to the plane of revolution. Suppose I ask you, why should I believe that there is a tilt? Suppose I said that the axis of rotation is perpendicular to the plane of revolution. This is a critical thinking question. If you can address that, then you are evaluating the existing heliocentric theory. Of course, you may accept the existing theory, that doesn't matter. You have gone through the exercise of critical thinking. And this should be an examination question. Of course, you can't repeat the questions because once you ask the question, its power is gone. You cannot repeat it. But ask similar questions. Why should I accept the Galileo principle of inertia as opposed to Aristotle's principle of inertia? The first time you ask that question, you are testing critical thinking abilities. But these questions are hardly ever asked in examinations because exams are typically 2 minutes per question. You cannot answer these questions in 2 minutes. So our exams are designed to discourage critical thinking. Our exams are designed to destroy the minds of students. So the words become fancy words. If you change that into words which have consequences to syllabus, textbooks, and exams, then there will be change.
Sure.
So I have no objection to the words, but there should be some follow-up. So the diagnosis that you mentioned is, the diagnosis is that there is no connection between the words and the actual practice.
Sure.
That's the diagnosis.
Sure. So can we spend a minute on this? You made this contrast between word-based thinking, which seems to be the cardinal sin for most sometimes researchers, mostly students, all of this, as against a truly cognitive activity of thinking. Can you sort of elaborate a little bit for us?
Yeah, let me take an example that came up in discussions with some students recently. That's the word gender. For example, in gender studies. So there is the biological gender, which is expressed by the words male and female. That applies to humans. It also applies to non-humans. It applies even to plants. So now if you're using the word gender in the context of biology, you should say, what does that word mean? Clarify the concept. Obviously, if you use the word gender specific to humans, it will not apply to plants. So you have to use the word male and female, male flowers and female flowers, in such a way that it would apply to humans and flowers at the same time. So one way of defining it is to say, male means sperm-producing things, and female means ovum-producing things, and some entities like plants can produce both. That's a very biological, clearly defined concept. But we use the same word gender in language. So gender agreement, which Hindi I have never mastered this. You say if it is kitab, you say feminine gender, and pustak is masculine gender. Is that the other way around? I don't know. But so you are referring to the same object. Obviously, book is not something that produces ovum and sperm. So that's a different meaning. You have to separate the meaning of the concept in language versus, language verb agreement and biological. Now you use the word gender to mean not male and female in the biological sense, but in human studies to mean masculine and feminine. What does that mean? If you're not clear about the word, you're just using the words without the concepts. Okay? I'm not going to unpack the meaning of the words masculine and feminine. I'm simply saying, at this point, you have to unpack the meaning. Not only that, you have to justify using those concepts. What generalizations can you make about masculine and feminine as concepts? What can you predict? What can you explain? If there is no answer, these concepts, these words should be banned from academia. Okay, I can make certain predictions using the words male and female in biology, but I don't know if there has been any arguments to show that these concepts are relevant for understanding, for stating generalizations, for making predictions in human cultural studies. In grammar, in linguistics, I can make an argument for saying gender, grammatical gender. I can give you the reasons. But if you move from grammar to culture, I don't know what the consequences are. So I leave that to you to decide.
In fact, that's interesting because my favorite example is again gravity. Every single person beginning from grade 1, grade 2 to masters would say if something falls down, why does it fall down? Gravity. But my assumption is to be able to say that, you should at least know some basic stuff like the difference between mass and weight, acceleration, momentum. Now, I don't know any of these things, but I somehow seem to say things fall because of gravity. And I liked it when you called this scientific dogma. This looks like science, but this is not scientific knowledge because this is purely word-based thinking. You latched onto a word and then labeled the phenomenon and said, okay, from now on we are going to use this for this. So it's literally like when you sneeze, you're supposed to say God bless, and when things fall, you're supposed to say gravity. So beyond that. So on that front, I was thinking if we can reflect about learning itself in a larger context, to slightly shift gears, especially with a bunch of prospective engineers and managers, and in Ahmedabad University, we keep coming across debates in artificial intelligence, machine learning, and so on and so forth, big data analytics and all of this. Coming from mostly defunct disciplines like English literature and all of that, I wonder, so what's the future of learning in this context? Especially because think of some paradigmatic instances of learning that we know. The 19th century learned man was someone who read a lot of things, who knew a lot of literatures. Probably the early 20th century learned man was someone who could say why things fall and things don't fall at the same time. Later on, it was probably someone who could solve problems related to poverty in the third world and so on and so forth. What is the learned man or the learned person today? What does this person look like? Or what are the prospects for learning if actually you're talking about these other systems which are going to do the learning for us?
Actually, I would shift from learned person to learning.
Okay.
Let's say, what is valuable learning?
Yeah.
That's easier, because in my view, the idea of learned person need not be part of education.
Sure.
But learning is. So the question of valuable learning is important. Now consider this. If you want to learn, let's say, history of Italy or history of Philippines, do you really need to attend classes, or can you learn it on your own? You can learn it on your own. There is so much of wealth available at the internet. Wikipedia, all you have to do is to type something and you get the stuff. You can read or watch videos and you can find out. If you want to learn, let's say, classical mechanics, you can do that without attending classes. You can go to the course at MIT on classical mechanics by Walter Lewin. It's a fantastic course. You don't need a teacher. You don't need to be in an institution. So the question should be, there are things that you can learn on your own. What is the function of an educational system, a formal education, where you have to go to an institution, sit in a classroom, take exams and so on? What's the function? When you can do that much more efficiently outside of the institution. I couldn't do that when I was a student. I couldn't learn classical mechanics by watching a video from MIT. It was impossible. Now it is at your fingertips. So if you hear a new word, say for example phonology, you can do it, type stuff or watch a video and understand it. So this is not the function of formal education, at least in higher education. What is it that an educational institution can do? Help you develop the capacity for independent learning. That is important. If you cannot learn on your own, if you want to learn it when you're 30 years old, the system of education has failed you. if the institution does not create joy of learning, if learning has become painful for you, then the educational system is doing disservice. If it doesn't enable you to develop the capacity for self-directed learning, that is to say, you decide what you want to learn and you can pursue it. If it doesn't develop the capacity to investigate things, to inquire, to think, so there are many things for which you do need help from a teacher. So if the institution focuses on where a teacher is needed, Walter Lewin, for example, at MIT cannot answer your questions. Only a teacher here can answer your questions. So you can watch the videos of Walter Lewin, come to class prepared and discuss. That's different. So the teacher, the physical face-to-face teacher and the video teacher are different. So this is what formal education should actually focus on. What textbooks, videos and the internet cannot do. And if there are certain things that these things can do, let the students learn from those sources and come to class. Don't waste time in the classroom. I think that is valuable learning. Okay. The role of formal education has shifted. Before writing was invented, you needed to learn everything from a teacher. But now, with the invention of writing, with the invention of printing, with the invention of the internet, the function of formal education has to change. It is no longer the same what it was like in the Stone Age.